Welcome to an awesome episode of Engine Power. Today we have a lineup that will satisfy any gearhead. First, we're going to finish up our Gen III 426 cubic inch Hemi that we dubbed Project Stray Cat. Now this engine is receiving twin turbos and it's going between the frame rails of the PowerStop Ultimate Challenger Sweepstakes giveaway that Mark and Tommy are assembling down in Detroit Muscle. Now they want to see around 800 horsepower at the tires, and this is the foundation that'll get them there.
Second up, we're going to get technical. We're going to show you a couple of things that you see us do around here that you may or may not know how to do yourself. So we're going to take the time and educate you on some procedures that every gearhead or hot rodder should know.
In case you missed part one of the Hemi build, here's a look at what happened. We removed a 6.1 liter Hemi out of a 2010 Dodge Challenger SRT8, tore it down to the bare block, and shipped it out to Sam Tech. When it came back, we washed it and got started with assembly. A forged Eagle crank went in as the backbone of the build, along with their H-beam rods and forged Mala pistons. We chose a catalog hydraulic roller cam from Summit Racing and linked it to the crank with a Howard's double row timing set and installed a new Melling oil pump. Mopar Performance lifters went in with new retainers, and the front timing cover went on. Underneath, we dropped on the windage tray pan gasket combo, the oil pump pickup, and sealed the bottom up with the factory pan.
Now let's talk induction, starting with the cylinder heads. These are the stock Mopar castings, but in the right hands can be turned into pieces that were comparable to the best aftermarket ones. We sent these to Tony Bischoff at BES Racing, who has a proven reputation for great achievements and records when it comes to making big horsepower. These received his signature CNC magic, plus they were meticulously hand finished. They were assembled with a spring package that complements our valve train. They also received a custom valve job and were sent to us ready to be bolted on the engine. Let's have a look at what that magic yields. Our reworked castings still utilize the stock hollow stem valves, which measure 2,080 on the intake side and 1,650 on the exhaust side, but it sure doesn't hurt the flow any because CFM is improved throughout the entire range. But for comparative purposes, our stock port flows 322 CFM at 600 lift. Our new port flows 367 CFM, which is a 45 CFM gain. On the exhaust side, our old port flowed 194 CFM, the new port 252 CFM for a 58 CFM gain. That's a massive improvement of flow across the board, and coupled with our planned pressurization, this Mopar is going to crank out some big numbers. Before the heads go on, a very important dimension needs to be checked, and it's going to determine whether the piston is above or below the deck surface at TDC, which is going to dictate which head gasket we're going to be able to use. First, set up the magnetic base dial indicator over the direct center of the piston. Now rotate the engine until you find the breakover point. Next, move the gauge to the deck of the block and make sure it's zeroed out. Move the gauge to the outside edge of the piston and take a reading. Now do the same on the other side. Those two numbers will be the same if the piston is squared up to the deck surface. These pistons are out of the hole 10 thousandths. Head gaskets are an important topic, especially in a boosted application, and these Cometic MLSs are our choice, hands down. They come in thicknesses from 27 thousandths all the way up to 120 thousandths to accommodate any combo. Now, when we come back, these gaskets and these cylinder heads are getting put on that short block. We're continuing on with our 426-inch stroker Gen III Hemi, and we're going to dress it out to long block form before it goes down to Mark and Tommy in Detroit Muscle. But for right now, it's time for some head gaskets. Remember, our pistons were 10 thousandths above the deck surface, so we're using a 40 thousandths compressed thickness Cometic MLS to seal this one up, making our calculated compression ratio 10.4 to 1. Our reworked heads can now be positioned on the dowels, and ARP head studs can be screwed into place. The Gen III Hemi has a specific head for the driver and passenger side. Make sure you mark them when it's coming apart and get the correct one back in its respective place, or it will just cost you time later on. ARP Ultra Torque is placed on tops of the washers and threads. Finally, the nut's going to be ran down and torqued to 105 pound-feet.
Same process for the passenger side, and we marked it as well. Now it's time to see if the factory push rods will work. Now, just because you've got a new aftermarket camshaft doesn't necessarily mean you need new push rods. Now, with that being said, lift and duration both directly affect the push rod length. Now, here's something else. Don't just listen to what somebody else has to say about the length of push rod you need for your engine. There are several other factors involved, like how much the block and the heads have been milled, the thickness of the head gasket, as well as the length of aftermarket valves. They all directly affect the length. We'll roll the engine to work on the number 1 cylinder. Now, drop in our Matco extended TDC indicator and rotate the engine so the number 1 cylinder is at TDC on the compression stroke. Drop in our adjustable push rods with them as short as possible. Now lay the rocker shaft assemblies in place and tighten them up, making sure the push rod does not contact the rocker. Extend the push rods until they make contact with the rocker. This is called zero lash. Since this is a non-adjustable rocker, we can now remove the assembly. Pull both push rods and we'll take their measurements using a large 12-inch digital caliper. We have 6,550 on the intake, 7,780 on the exhaust. Now we need to add 50 thousandths for lifter preload. Our final is 6,600 on the intake, 7,830 on the exhaust, so those are the two we'll order. Anti-seize can go on the crank snout and on the inside of this ATI balancer we got from Summit Racing. Since the Eagle crank is keyed, a new balancer was in the parts list. It's torqued to 140 pound-feet. A new water pump is a must in engine builds like this. We don't want to take any chances when handing it off to Mark and Tommy. ARP fasteners from the accessory kit hold it on.
To give the engine a different appearance, we covered the intake manifold in VHT's high temperature Wrinkle Plus textured coating. It's good to 350 degrees. New chromatic gaskets will make the seal from it to the cylinder heads, and more ARP fasteners will cinch it down.
We're putting the factory injectors back in for now. Mark and Tommy will change them when they install the Hellion turbo system in their shop. We're just plugging the holes. A new thermostat goes in now. It's the factory 203-degree unit. The sensors are next, starting with the cam sensor. Now the crank, knock sensors, oil temperature, and oil pressure. Now the water temperature. The factory throttle body goes back on, along with the belt tensioner and the idler pulley.
Trend Performance has been our pushrod source for the last couple of engines we've built. They are hands down one of the leaders in innovation when it comes to pushrods, wrist pins, and valve train testing and evaluation. These have a 5/16 inch diameter and a 105 wall thickness. The ball ends are factory OEM Hemi size at 5/16. The rockers are oiled through these small holes in the stands that are drilled into the heads. The intake shaft assemblies can go on now and torqued to 25 pound-feet, followed by the exhaust shafts that are torqued to the same spec.
These are the real reason we painted the intake manifold. We wanted these billet valve covers to catch your eyes as much as possible when you saw them. This was a really fun build, and Pat and I are super excited to be a part of it for a couple of different reasons. The first one is it's getting twin turbos, and it's going to make some really big power at the tires. Second, one of you lucky viewers are going to have a chance to win the entire project once the Power Stop Ultimate Challenger Sweepstakes opens up. So make sure you keep your eyes peeled.
Like they say, timing is everything. Coming up, how to maximize it.
Every part of an engine, from bone stock to full race, is important in its function, and distributors are a subject we get a bunch of questions on. So today we're going to slow it down and go in detail on some how-to tech on the engine's nerve center, so pay attention.
Ignition timing is obviously a crucial part of engine tuning, and having total control of the timing helps maximize an engine's output. Now, the distributor is what dictates when the energy fires the spark plug. So today, we're going to show you how to lock one out. Most distributors you deal with have a timing curve in them. That means when the engine is idling, the timing is set at its minimum position. As the RPMs are increased, weights and springs in the distributor move the position of the rotor to advance timing, sometimes as much as 24 degrees.
Let's say, for example, you have an engine that checks at 10 degrees of ignition timing at idle, say 800 RPM, and then you increase the RPM watching your timing mark until the advance levels off, say 5,000 RPM in our case, and it now checks at 34 degrees. That means you have 24 degrees of centrifugal or mechanical advance in your distributor. Different distributors will vary from that up or down, but it's important to check yours to see how much yours has in it. The vacuum advance on a distributor is there for the sole purpose of emissions and drivability, pulling additional ignition timing in at light load and partial throttle situations like normal everyday driving. That's why it's important to have it hooked up to a manifold vacuum source instead of a constant vacuum source. We like to have total control over the timing in the engines we build. Most are high-performance bullets that are built for a specific purpose. MSD distributors have a provision in them to lock the distributor out if you want, and most racers will want to control their ignition curve electronically with a box like an MSD Digital 7. They don't want to rely on springs or weights to set their timing curve. The first thing we need to do is remove the rotor. This gives us access to the springs and weights. As RPM increases, the weights are forced away from the center, which moves the rotor, advancing its position. This is what we'll remove to lock out the centrifugal advance. The springs need to be removed, which is easy. Just pry them off the post. Now the weights can be removed, and the roll pin securing the bushing can be tapped out and removed, along with the bushing. Back on top, I'll separate the rotor shaft from the main shaft and remove the nut and washer along with the advance bushing. Rotate the rotor shaft 180 degrees and align it with the hole on the opposite side. Secure it down. Replace the bushing and tap the roll pin back into place. With all of our unused parts left on the table, the rotor can go back on. Now there's nothing left in the distributor that will cause a timing variance at any RPM, and that's how you lock out a distributor.
Now you know how to modify one. Here's an easy way to install it.
Installing a distributor is a popular topic in our email bag, and most of them are asking, how do we get so lucky dropping in a distributor and getting an immediate fire up every time?
Well, there's no luck involved. It's a simple understanding of positioning, and the process we're going to show you here applies to all engines that have distributors.
The first thing to do is make sure the #1 cylinder is coming up on top dead center on the compression stroke. There's a couple of ways to do that. The first and generally easiest is to have the #1 cylinder spark plug removed. Now place your finger over the hole and turn the engine over slowly. When the piston comes up on the compression stroke, it will force air out of the cylinder and push your finger off its seal like this.
The second way is more involved and requires you to pull the valve cover. When you turn the engine over and both valves are closed and the rocker's not moving, you're coming up on the compression stroke. Now slowly turn the crank to get the timing mark, or 0 depending on your balancer, about 30 degrees before on the timing pointer. To put it in simple terms, there are 360 degrees in a circle, so that means 30 degrees is a little less than 1/10 of that, which is a very small distance. Now it's time to drop the distributor in. The important thing is to position the rotor where you want it, not where it falls. This is important for your wire routing to look neat and clean. To make it drop all the way down, all you have to do is rotate the engine and the distributor will index the oil pump drive. Then simply reverse the rotation back to 30 degrees before TDC. Now the cap goes on. The wires are routed to the spark plugs, and here's the results. Hit her.
So all you need to do is follow that simple procedure and you'll never see flames come out of your carburetor again. Plus, it'll just make your life simpler.
One more thing about distributors. You can't run an iron gear on a steel cam. In this case, the materials hate each other and you'll get almost immediate failure on your distributor gear. A composite or bronze gear like this one from MSD will solve the problem. The bronze material is softer than the camshaft gear, allowing for a friendly mesh between the two. The gear isn't hard to change, but its position on the distributor shaft is crucial. Luckily, MSD provides the correct dimensions for its placement on this sheet. Simply remove the pin and press it off and the new one on. Making sure it's at factory spec, drill a new hole for the new pin and you're good to go for the long haul. A great way to combat that interior heat in your race car or street beast is with Lizard Skin's ceramic insulation. Coating the entire interior will reduce your temps inside your ride by up to 30 degrees or more. An application is made easy by utilizing their available Super Pro application kit. Covering it with their top coat afterwards will give a durable, abrasion-resistant, glossy finish that will improve its performance even more. And you can check out the entire product line at lizardskin.com.
Powertrain Products, Inc. offers front and rear differentials for all domestic and most foreign applications. Now, these things come fully assembled, upgraded over OEM, and fully tested. Now, get this, they all carry a full 3-year unlimited mileage warranty. Now, Powertrain Products also offers engines, transmissions, transfer cases, and differentials used or remanufactured, and they all carry a new improved no-fault warranty. Now, to find out more information on the parts you need and the warranty it carries, visit their website at shopengines.com.
Rock Auto has a cool feature on their website that lets you search for a part number even if some of those numbers are actually missing. Simply put in what you know for sure, and then for the unknown, just type in a star and click the search button. It will pull up every possible solution from their enormous database, narrowing down the possibilities in a hurry. When you find the right part, just simply add it to your cart and then you're ready for checkout. Or you can keep shopping for almost anything you could ever need for your ride, and you can find it all by logging on to rockauto.com. Today's tech tip is going to seal the deal on any engine that you build from mild to wild. We're talking piston rings. Now, they're probably the least glamorous of all engine parts, but arguably one of the most important. They're unique in the fact that they're a moving seal under extreme pressures and temperatures, but their job description is simple: to seal up cylinder pressure. Depending on the ring's application, they'll vary in design and material. Let's start with material. At its basic level, the top and second rings are constructed of cast iron. They're easy to machine and cheap to produce, and they're used in applications for very simple engines like air-cooled lawnmowers, farm tractors, and even automotive applications from the 1970s and older. The oil control ring that typically goes with those are a 3-piece design that scrapes excessive oil off the cylinder. They contain an expander with 2 outer rails, and they're typically constructed of inexpensive steel. It's highly recommended to use a ring expander to install cast iron rings. They tend to be a little fragile when installing.
Performance engines and modern power plants still use a form of a cast iron ring, but they are improved in both material quality and the addition of special coatings. They are typically thinner for less drag and are better equipped to handle the increased heat and pressure of these types of engines. Here's a look at how an early style cast top ring and a newer style one compare. Now notice the difference in the actual thickness of the ring and its radial width. Now the smaller ring has less surface contact with the cylinder bore, which equates to less drag and improved sealing. Oil rings have also decreased in size to further reduce friction, but by design they still maintain excellent oil control. This late model oil ring set is pretty trick. It includes the same components as the early style, like the expander and 2 rails, but their thickness and width are much smaller. The late style is only 3 millimeters thick when it actually fits in the ringland. The old style is 3/16. That's a 69 thousandths difference. Now multiply that by 8 in a V8 engine and you've reduced a lot of surface area and a lot of ring drag on the cylinder, which frees up horsepower.
High-end racing engines have rings made out of more exotic materials, like different grades of tool steel, and they're designed for the most extreme applications where a cast ring will just outright fail. And ring prices vary widely from about $30 a set for a stock 350 Chevy to over $1,000 a set for a full-tilt race bullet.
The next time we talk about rings, we'll get into proper gapping, using both manual and electric grinders, plus where and how to set the gaps up properly size-wise for any given application.